today, we are going to prove that lines are parallel given information about congruent corresponding angles, alternate interior angles, or same-side interior angles. Now, when we last left off, we were given the fact that two lines are parallel, and if two lines are parallel, then we can say, what about corresponding angles? They are congruent. Okay? If we have two parallel lines, what can we say about alternate interior angles? If we start with parallel lines, what can we say about alternate interior angles? They're not parallel, they're congruent. If I start off with two parallel lines, what can I say about same-side interior angles?
They're opposite.
They're not congruent.
They're corresponding.
They're not corresponding. They are supplementary. And supplementary means what?
Equal 180.
Two angles summed together to equal 180. Okay? So, guys, today we're going to look at the reverse of that. We started with parallel lines before. Today we're going to use those same three tools, corresponding angles, alternate interior angles, and same-side interior angles. We're going to look backwards and we're going to say, can we prove that these lines are parallel? Okay? Okay, up here I have a drawing with two parallel lines. And we have numbered angles 1, 2, 3, 4, 5, 6, 7, and 8. We're going to start off, and this will be a review from the last section, is that we're going to start off with parallel lines. Who can give me an example of corresponding angles? Hey, Tyler?
Would be 2 and 6.
2 and 6. Now remember how we're doing that. If I draw the box around,
I know 3 and 5 are 1, so we're 4 here.
2, just a minute, 2,
Yeah, that's what I meant.
all right, so we said angle 2 and 6 are corresponding. 2 is in the upper right, 6 is in the upper right. If we have parallel lines, those are congruent angles, okay? We said angle 2, we said angle 2 and angle 6 are congruent because they're corresponding angles with parallel lines. How can we tie angle 4 and 5 together?
I don't know.
How can we tie angle 4 and 5? They're what? Okay, AIA, which stands for? Alternate interior angles. So here's my parallel lines right here. Here's one parallel line. Here's the other parallel line. Here's my transversal. Okay? Is angle 4 and angle 5 between the two parallel lines?
Yes.
They are. Are they on opposite sides of this transversal here?
Yes, they are.
They are. And if we start off with parallel lines, what can we say about angle 4 and angle 5 then?
They're alternate interior.
They're alternate interior angles with parallel lines, and it makes them
Congruent?
congruent. So we could say angle, whatever the measure of angle 4 is going to be identical to angle 5. Okay? I know we're repeating this again, but we have to understand those three concepts. Okay? Now let me clear off some stuff here. Yeah, I don't think I'll be able to get that. Probably can. Okay. Who can give me an example of same-side interior angles?
Ooh.
Okay, Eli?
4, 6.
4 and 6, okay? Here again, they're between the parallel lines and on the same side of the transversal. So can we say angle 4 and angle 6, are they congruent?
No.
No.
No, but what can we say about them, John?
They're same side interior.
Yep, which means what?
They're corresponding.
Not corresponding, but
The other one.
you're half correct.
Supplementary.
Supplementary. So mathematically, we could say the measurement of angle 4 plus the measurement of angle 6 all have to be set equal to 180 degrees. Okay? So, with that in mind, what we're going to do again today is we're going to go backwards. We started with parallel lines here. Today we're going to start with two lines that are not parallel, and we're going to prove that they're parallel by using corresponding alternate interior and same side interior. Okay? Okay, everything we're going to look at today is the converse. And when I say converse, we're talking about looking backwards at something. Okay? So the converse of the corresponding angles postulate says if corresponding angles are congruent, then we can say that two lines are parallel. That's just opposite of what we were studying before, where we started with two parallel lines. We could say corresponding angles are congruent. Today we're saying if we start with two corresponding angles that are congruent, then we can say my two lines are parallel. Okay? So if I take a look at our diagram up here, angle 1 and angle 2 are both in the upper left-hand corner. So they're corresponding angles. Then I'm going to look at the diagram and I'm noticing that angle 1 and angle 2 are congruent. Now the converse says if corresponding angles are congruent, then we can say the two lines are parallel. And I'm going to write the word then, okay? We can say this. If this is true. Okay? I'm going to keep stressing that we're going backwards on this. Okay? If this is true, then the two lines are parallel. All right, that takes us to the second converse, and it says the converse of the alternate interior angle theorem. Maddie? Thank you. It says if alternate interior angles are congruent, then the lines are parallel. So think of this as an if-then statement again. If angle 1 and angle 2, which are alternate interior angles, if those are congruent, which it shows on the drawing that they are congruent, then, so I'm going to write if, then I can say the two lines are parallel. So, that's not a big jump from where we were, we're just thinking backwards, okay? So that leaves us the last item, okay? The last item which we need to think about, which is same side interior angles. Okay? Now I'm going to pause this, if it'll work for me. Okay, I'm going to pause the recording to allow you to draw this. This is the last converse, which is the converse of the same side interior angles. Okay?
You're recording right now.
I know I am. Okay, so I'm going to pause this. I'll let you draw this and write the converse.
Readable?
Okay. All right. Now the converse of the same side interior angle theorem states if same side interior angles are supplementary, okay, then the lines are parallel. Again, supplementary is the sum of two angles that add up to what?
180 degrees.
180. So I'm going to write that above there, just for your notes, 180 degrees. So if the two angles are supplementary, then the lines are parallel. So let's back up to our drawing here. So there's our diagram. So I have my first angle, which is 110 degrees, and my second angle, which is 70 degrees here. Notice how they're not congruent, right? But we can say if these two add up together to be supplementary angles, to be 180 degrees, then we can say that line S and line T are parallel. So 110 plus 70 is 180. So I agree that these both total to be supplementary. So then we can say that line S and line T are parallel. So we now have three things, or three theorems, that are backwards or converses of what we've been talking about to prove two lines are parallel. All right, let's take a look at the first theorem up here. And it says if two lines are parallel to the same line, then they're parallel to each other. Okay? So I have taken the time and I've drawn three lines here. And let's use this example right here to talk about what we have up here for this theorem. It says if two lines are parallel to the same line, okay, then they are parallel to each other. So what are we saying? Let's say if this line is parallel to this line, and we say this line is parallel to this line. Note how we're saying this. This line is parallel to this line, and this line is parallel to this line. Then we can say that this third line is also parallel to the first line. Now that seems like common sense, but this is telling us that this is an accepted fact. All right. Let's go to this theorem. It says in a plane, if two lines are perpendicular to the same line, then they are parallel to each other. So let's go to a drawing here, and I want you to put on your notes, and then this will make more sense. Here's that drawing. Take a second to write that, and then we'll walk through that theorem. Okay, here's our diagram. I've got line S, line T, and line R here. None of those lines are parallel. We don't have anything up here that says that they're parallel. The only markings that we have is that the intersection of line S and line R, angle 1 is perpendicular, and the intersection of line T and line R, angle 2, is perpendicular. What this theorem says, if in a plane, two lines are perpendicular, so in our example, line S and line T are perpendicular to the same line, which is line R, they're perpendicular to the same line right here, then they are parallel to each other. Then we can say that these two are parallel. Now, the first three are just looking backwards. Those tools are just looking backwards of what we did before. And the last two are new thoughts that we have. that we've gone through. Okay?
If we add on to why this is true, what kind of angles are 1 and 2?
Corresponding.
Corresponding. And since they're perpendicular, that makes them right angle, which makes them 90 degrees, right? So since angle 1 is 90 degrees, and angle 2 is 90 degrees, and they're corresponding angles, that means the lines must be,
Supplementary.
no, the lines must be
Oh,
parallel.
Parallel, yeah.
So we can prove that this is true, that this theorem is true, by using the converse of the corresponding angles postulate. Know the angles are congruent, the corresponding angles here are congruent, so therefore these lines, somewhere here, you can draw straight lines with this mouse. These lines are parallel, okay?